Hi, welcome back. Right, in this video I'm going to be talking to you about tangents and normals. Of course, it's from the differentiation chapter. Okay, so how do we find an equation of a tangent and a normal to any given curve? Well, first of all, what are tangents and normals? Okay, I'll talk to you about that a little bit first, and then after that I'll show you some examples of examination style questions where you're asked to find an equation of a tangent or normal. So this is a generic curve, okay? Looks kind of like a cubic, doesn't it? But I've just given it the equation y equals f of x, just to show you that this is going to be able to be applicable to any particular given curve you're given. So maybe you're trying to find an equation of a tangent or normal at that point there. I could choose any point in the curve, I've just chosen this point. Well, what is a tangent, first of all? Well, a tangent at that point is a straight line that just touches the curve at that point, okay? And if you saw my previous videos on differentiation, I was talking to you about finding gradients at points, and that's the same as the gradient of the tangent at that point as well, okay? So what we would do is, because it's all about gradients, is we'd find out what the derivative, what the derived function y equals f of x is, okay? And what we'll do is we'll work out what that first derivative is, okay? I've labelled it f dash x because I call that y equals f of x, or you write dy dx. The choice is up to you, okay? So the first thing you do is to differentiate the given function, okay? And then you substitute in the given point, okay? Now suppose the point has got x coordinate a, in which case the y coordinate is going to be f of a, of course. Okay, so if you're given the x coordinate, you can work out what the y coordinate is by substituting. So that's got any generic point a, f of a. Okay, and once you've found the derivative of f of x, what you would then do is you'd substitute your x coordinate in, and remember that gives you the gradient of that particular point. Okay, so once you've differentiated this, substitute in the x coordinate, and that gives you the gradient of this tangent. Okay, so this here is going to be the gradient of the tangent. What f dash a actually is. I'll put in brackets there, that's gradient of tangent. Okay. And then all you do is just use the equation of a straight line, which is, remember, y minus y1 equals mx minus x1. So let's write that down. So y minus y1 equals mx minus x1. Remember that from the straight line graphs unit, okay? And so we'll have y subtract the y coordinate, which is f of a, okay? And then that's equal to the gradient, which will be this f dash a, sometimes called f prime of a, and then x subtract the x coordinate, which is just a, okay? And that's, in general terms, how you do it. That will be your equation of the tangent, okay? Now, suppose you asked us to find the equation of a normal. Well, what do we mean by a normal? Well, a normal is a straight line that's 90 degrees to the tangent, okay? So it looks something like this. Okay, and I put in a right angle there to show it's at 90 degrees. So I'm going to label that, that's the normal, okay? And this one here, I'll just label that, that was the tangent. So you can do the same thing, except it's going to be for the normal. So when I say the same thing, I mean it's another straight line. So you're going to use this again, y minus y1 equals mx minus x1, okay? Only the gradient is going to be different. Do you remember the rule for gradients of perpendicular lines? Yeah, the two gradients have got to multiply to get -1, okay? So when this is the equation of the tangent here, the equation of the normal is going to be what? That's your opportunity to think about it before I write down the answer, okay? Well, it's going to be y minus f of a again, because it's still a straight line through the same point, okay? The only thing that's going to be different is the gradient, okay? So if the gradient of this is f dash a, then the gradient of the normal will be -1 over f dash a. Remember, for the normal, you take the reciprocal, multiply by -1, okay? And then that will be x minus a, all right? So, quite briefly, that's your method, okay? So you've got either an equation of a tangent or a normal to find out, okay? The first thing you do is differentiate your given function, put in, substitute, x equals whatever the coordinate is, okay? X equals, in this case, a. Find out what the gradient is. You're either using that gradient for a tangent, okay? Or you're doing the negative reciprocal, if you like, for the normal, and then you just substitute in the x coordinate and the y coordinate, okay, in order to work out what what your final equation is. Right? And then once you've got that, obviously you can simplify it, write it in the required form, whether it's y equals mx plus c or ax plus by plus c equals 0. But that's your generalization. Coming up next is going to be some examples of working out equations of tangents and normals. Okay, so let's go over an example, shall we then? So here, find the equation of the tangent to the curve y equals x cubed plus 3x squared, subtract x, subtract 3 at the point 2, 15. Okay, if you want, just pause the video, have a go at it, and then unpause it, see if you got it correct. Okay, so the first thing you want to do is you want to differentiate. Okay, now when you're doing these questions, just look out for key words. Okay, so you find the equation of the tangent. Okay, I'm going to underline that. Okay, and as soon as you see the word tangent, you need to think this is all about gradients. Okay, it's all about gradients. And when it's all about gradients, you differentiate. Okay, because you'll notice nowhere in the question does it say you have to use calculus. Okay, you have to find a derivative of something. Okay, but that is the standard method. So your first method marks are always going to be from differentiating this here. Okay, so it's important you realise that as soon as you see the word tangent, you differentiate. Okay, so let's differentiate this. So the first term, that would be 3x squared. Second term, that would be plus 6x, and then this term will be -1, and then that's 0. Okay, so that's what we get when we differentiate it. Okay, so that gives us an expression for the gradient at any point on this curve, and what we want to do is use this point. So we'll substitute in the x coordinate. Remember, you only need to substitute the x coordinate because your derived expression dy dx is in terms of x only. Okay, so at x equals 2, let's find out what the gradient is. So dy dx is equal to, we just put it in, so 3 times 2 squared, so that's 3 times 4, so it's going to be 12, plus 6 times 2, which is 12 again, and then subtract 1, okay, so that's 24, so that's 23. So that means the gradient at that point is 23, okay? So I'm just going to write down there that m, the m we use in our equation of a straight line, is equal to 23. And then we're going to use the equation of the straight line, and we write it down here as a reminder, y minus y1 equals mx minus x1. We use that equation to write down the equation of the tangent, okay? So y subtract the y coordinate, which is 15, and that's equal to gradient 23, x subtract the x coordinate, which is 2. And there you go, that's it, it's done. Maybe we just tidy it up a little bit. Okay, so y minus 15 equals 23x subtract 46. How should we leave it? Well, let's just leave it y equals mx plus c, shall we? Y equals 23x, then 46, negative 46 plus 15, negative 31. Okay, so it's going to look like that. Okay, that's it. We're all done. Now, what does that look like on a graph? So I've got a chance here just to sketch this out. Okay, so that will factorise to this. Bit of a challenge for you. Maybe pause the video, see if you can get it to factorise like this. Okay, otherwise just go with it for the moment. You can confirm it, of course, just by expanding the brackets. Okay, expand the brackets to get this. Okay, and then this is the curve that we get passing through -1, 1, 3. Sorry, -1, 1, -3. There we are, -3, -1, 1. And the point 215 is going to be about there, say. Okay, do you agree with that? And so what we're doing is we're finding the gradient of that tangent line that I'm just drawing in there. Okay, and so that kind of makes sense next. It looks fairly steep. We had a gradient of 23, and the y-intercept, going all the way down to -31. Okay, but visually that's what it looks like, and we've just found the equation of that line. Okay, now notice we're able to do that without actually drawing this graph. Okay, I only put this graph up right at the end. Okay, and so that's why it's important that you quickly get to grips with all the algebra stuff, the equation of straight line stuff, and the differentiation stuff. So because you haven't got time in an exam to sketch, this is lovely, it shows you what's going on, but you haven't got time in an exam to draw this out. Okay, so I'm hoping you found that question useful. Okay, coming up is another example. Okay, so here's another example. Okay, so find the equation of the tangent to the curve y equals x squared minus 6x plus 10 at the point 3, 1. Okay, so again, just reading through the question, I would normally recommend you underline the word tangent, okay, because that tells you, informs you what your next steps are. Okay, remember, as soon as you see the word tangent, you must think it's about gradients, and that means you need to differentiate the given function, okay? So the first thing you need to do is to find dy dx. So let's do that. So dy dx is going to be 2x subtract 6. Hoping you agree with that. The next step, you want to find the gradient at the given point. Find the gradient at the point 3, 1. So when x equals 3 and x equals 3, find what the gradient is. So dy dx is equal to, it's going to be 2 times 3, which is 6, subtract 6, which is 0. So the gradient is 0. Okay. Then what we do is just use the equation y minus y1 equals mx minus x1. Okay. So I'm just going to put it in there just to make it clear that the gradient we're using here, m equals 0, because we can substitute it in. Then substitute this coordinate point in. So y subtract the y coordinate 1 equals gradient 0. Oh, well, let's write out the rest of the line. X subtract 3, okay? But the reason I said O, so it wasn't a joke because it was like that, okay? It's just the right hand side has just become 0, isn't it? Okay, and so you get y equals 1, which you might think looks like an unusual answer, okay? But the reason I've designed this question is because I want to show you what it looks like on a graph, okay? So this is what it looks like on a graph, okay? So the equation y equals x squared minus 6x plus 10, if you complete the square, it looks like this. And so when you sketch it, it looks like that, okay? And notice that the coordinate point 3, 1 is the minimum point there. Okay, it's the minimum point. And so the tangent at that point is going to be parallel to the x-axis. It's going to be a flat horizontal line, okay? And so if you sketch the graph, you can just see that the equation is going to be the line y equals 1, okay? What this calculus method has done for us is just confirmed that that is the case, okay? So the reason I use this example is because it was slightly unusual, okay, because the gradient is just a flat horizontal line, okay, but showing you that, yes, the process, the method still actually works. And you shouldn't be surprised if you get a gradient of 0. Just bear in mind that correlates to a horizontal line, okay. If you can, if it's convenient, just draw a quick sketch just to make sure that, you know, your working is of course correct, okay. So that was my second example, okay, and there's another one coming right up. Okay, so here's the next example. So find the equation of the normal. So this is going to be a little bit different, isn't it? Okay. Find the equation of the normal to the curve y equals root x at the point where x equals 9. Okay. So there's two things that are different about it. One is we're going to find the equation of a normal, not a tangent. Okay. And the second thing is, notice a coordinate point wasn't given. You're just given x equals 9. Now we need to know what that y coordinate is to be able to use in our equation of a straight line. So that's something else that we're going to have to do as well. Okay. So as with before, okay, when you see the word normal, okay, you need to think about the fact that you need to find a gradient, which means you have to differentiate again. Okay, so the key words you're looking for in a question like this are tangent and normal, and that means you're going to have to differentiate. Okay, so let's find dy dx. So we're going to have to differentiate that. Now you might be thinking, well, hang on, yeah, how do we differentiate that? Well, you should know, you should remember that when it's not in index form, you're going to write it in index form. So I'm just going to rewrite that as y equals x to the power of a half, okay? Because that's going to help us to differentiate it. Because remember, our rules of differentiating with algebraic terms is to have it in index form, okay? So root x can just be written as x to the power of a half, okay? Then we can differentiate that quite easily. That's going to be a half x to the power of negative a half, okay? Just like that. Now, for the purpose of this question, I'm just going to rewrite it slightly, okay? So remember, x to the power of negative a half is the same as 1 over x to the power of a half, okay? And that's the same as 1 over root x, okay? So that means that 1/2 of that, if I just put the half there, right, so it's a fraction, numerator is 1, denominator is 2, so numerator 1, denominator 2, okay? And so it's like this. So that's exactly the same as 1 over 2 square root of x. Alternatively, you just use your calculator, but I'm against calculators, okay, kind of old-fashioned that way. So what do we do next? We substitute in the point x equals 9, okay, and we can work out what the gradient is. So dy dx is going to be, and you either, as I said, put it into that, use your calculator, just make sure you include the brackets in the right places, okay, or you just, like me, put it into that and see what you get. Okay, so you get, just put some work inside it, 1 over 2 times square root of 9, okay, and the square root of 9 of course is 3, so 1 over 2 times 3, that's 1 over 6, okay? And if you did use your calculator, maybe you got the same answer. Or maybe it's just a good idea just to check, because you know, using your calculator is quite an important part in mathematics, isn't it? So the gradient is just going to be 1/6, okay? So is that the gradient we want to use? So do I then write down, therefore, m equals 1/6? Well, no we don't, okay? The reason is because we're finding now an equation of a normal, okay? It's not a tangent, it's a normal. Now let me just show you again what a normal actually is. This is the graph of the question that we're trying to solve, okay? So this is the graph of y equals square root of x. If this is new to you, just go with it for the time being, okay? But basically it's a parabola that looks like it's on its side, okay? It's still a parabola, basically, okay? And there's no negative parts because that's the positive square root of x only. That is different from this. It's not written as y equals positive or negative root x, okay? It's just written as the positives, which means that you're only interested in positive y values only. So the graph looks just like that. So the point where x equals 9 is there, say, okay? And so the tangent would look like this, wouldn't it? Okay, if I just try and draw a tangent through that point. The normal is at 90 degrees to the tangent, so the normal looks like this, okay? There we go, the normal looks like that. So that's what we're trying to find, the gradient of that line there, okay? So what that means is, this gradient of 1/6, that corresponds to that. You can see it's a reasonably flat line, okay? The gradient of the normal we want is going to be -6, okay? You can see it's negative because it's sloping downwards, okay? So remember, you take the reciprocal of that, multiply by -1. So the gradient you need, very important, okay? That's another reason why you should underline that word, because a common mistake is just to substitute that into the final equation, okay? And you just got to be on the lookout if it's a normal, okay? So I'll just keep that there for the time being. So in our equation, y minus y1, okay, you'd have y subtract 9, sorry, no, y subtract the, well, we're not going to get the y coordinate, have we? Well, we better work that out, I suppose. When x equals 9, dy dx equals this, and let's just write it in here, shall we? And y equals, what's that going to be? Yes, square root of 9 is going to be 3. Okay, so ready to go. So y minus y1, y minus 3 equals the gradient m -6x subtract x1, which is 9. Okay, so that's it. That's our equation of a normal. Let's just, I have to get rid of that now. Let's just rewrite that a little bit. So y minus 3 equals -6x plus 54, and so y equals -6x plus 57. Okay, that sounds about reasonable, doesn't it? Because look at that normal, it's going, the y-intercept is going to be way up there, so the 57 sounds quite reasonable, doesn't it? Okay, so yeah, that's it. That's that question. Okay. A follow-on to that question is sometimes, let's just get there. A follow-on to that question is sometimes, where does the normal intersect the x-axis? Okay, sometimes you're asked to do that as a follow-on question. Okay, so I know I didn't write it down. I'm just using the opportunity to talk about what might come next. To find where the normal cuts the x-axis, where the normal crosses the x-axis. Well, that's quite straightforward. You can see where it crosses the x-axis, the y-coordinate there is 0. Okay, so what we'd then do is we just down by here, we then find out what happens when y equals 0. Okay, so let me just first of all highlight that as our answer for the question given, and then just put in y equals 0. So you get 0 is equal to -6x plus 57, so 6x is equal to 57, and then x is equal to 57 divided by 6. Well, I know 57 divided by 3 is 19, so that's going to be 19 over 2, okay? Or if you want, that's going to be 9.5, okay? If that pleases you. And so that's it, okay? If you need a coordinate, of course, then you just write down, you know, the coordinate of 19 over 2. Top heavy fractions are best. 0, okay? Then yeah, that's it. Okay, that's that question. I'm hoping you found that question helpful to you. Okay, and I hope you found this whole video helpful. I hope you're finding the whole differentiation thing going really, really well. Okay. Of course, the thing to do is just practice lots of questions. Okay. All right. I'll see you again.